right, this is the last of our special products, and it's called a sum and difference product. All right, sum means addition, difference means subtraction. This is a special product where you have the sum of two terms, say 2x plus 3, times the difference of exactly the same terms. They have to be the same, one of them plus, one of them minus. The plus does not have to come first, but I do that a lot when I'm just making up problems. When you do these, let's see what happens. Let's do it by FOIL first. 2x times 2x gives me 4x squared. The outer product is negative 6x. The inner product is positive 6x. Because they are opposites, they cancel out, and you have no middle term down here. Go to the last. Positive 3 times negative 3 gives you negative 9. Now, I'm really kind of asking you to take my word for it. Every time you multiply a sum and a difference product, this is going to happen. Let's look at least one more. Let's suppose I have 5x minus 8 times 5x plus 8. The product of the first is 25x squared. The outer product is 40x. The inner product is negative 40x. Well, those become 0. The product of the last is minus 64. So if you know that, then from now on, I'm not even going to talk about, if I've got a sum and difference product, I'm not even going to talk about the outers and inners because I know they're going to cancel out. So all I'm going to have to worry about is the first and the last. Let's look at a few. All right, the first problem is a minus 2 times a plus 2. It is a sum and difference, so when I multiply, I have a squared. I don't have to worry about outers and inners. A negative 2 times a positive 2 gives me minus 4. You always get square of the first minus square of the second. All right, next one. I have 8x minus 3 times 8x plus 3. Product of the first, 8x times 8x is 64x squared. I do see that there's sum and difference of the same quantity, so I won't worry about outers and inners. Product of the last is minus 9. The next problem, at first people look at it and go, oh my, I've got to do a binomials and I've got fractions in there. But it's not bad because it is a sum and a difference of the same quantities. So, product of the first, 7x times 7x, is 49x squared. Don't care about the outers and inners. Product of the last, negative times positive always gives me negative. The tops, 1 times 1 is 1. The bottoms, 4 times 4 is 16. Not bad. Number 4, I have 2p plus q times 2p minus q. Yes, it's a sum and difference. The product of the first, 2p times 2p is 4p squared. Skip the outers and inners. Positive q times negative q is negative q squared. All right, a few more. I have 5x minus 0.8 times 5x plus 0.8. 5x times 5x gives me 25x squared. Don't care about outers and inners because it is a sum and difference product. Negative times positive is negative, and it's going to be 0.64, and it could be 0.64. That 0 in front is optional. All right, x plus 1 times x minus 1. It is a sum and difference product. I have x squared. The outer product and the inner product don't matter, and I have minus 1. Next one, I have 7x minus 7z times 7x plus 7z. Product of the first is 49x squared. Outers and inners, irrelevant. Product of the last, negative times positive is negative. It's also 49z squared. Don't forget your squareds. Okay, one more. I have 4x minus 5 times 4x plus 5. I see that it's a sum and difference product. That's going to give me 16x squared for the first minus 25 for the second. So if you recognize that it is a sum and difference product, then you get to ignore the outers and inners. Just be careful, make sure that it truly is a sum and difference product before you try to use this shortcut.